All right, guys, welcome back. Lesson 111. So today we're going to be dividing scientific notation, which is not going to be very hard. That's why it only has 2 examples. And it's not very hard because you should already know certain properties of exponents that I told you about. And I always tell you, please, when you have these types of problems, divide them into 2 parts. The one that has the actual numbers, and then the one that has the powers of 10, right? 10 to the 8th or 10 to the 4th. And that's what we did when multiplying. So when dividing, I don't see why we would do this any differently. And so I'm going to show you the examples, and I'm not going to go over the 150 kilometers that they say that one astronomical unit is, because first of all, you guys don't really know that in kilometers. You know it in miles. I hope that everybody knows that one astronomical unit equals 93 million miles, which is what it is. One astronomical unit equals 93 million miles. But that's neither here nor there, and I don't understand why your book is trying to say that, because they make it then into a unit multiplier question, and that's not what we're doing here. We're trying to divide scientific notation numbers. And so, yeah, let's get into this amazing lesson. Here we go. Okay, so getting into example number 1, we have 6 times 10 to the 8th over 1.2 times 10 to the 6th. So before I even tell you what you're going to do, I want to point out and remind you of this property of exponents, that if we have a base with an exponent divided by the same base with a different exponent, then what we're going to do is we're going to have the answer be the same base, but the exponents are going to be subtracted. So we're going to subtract a minus b. And that's what you have to remember to be able to do all these problems. And I'm not just saying these on the board, but always for division of scientific notation. And then we're just going to do it in 2 parts. I always tell you, please divide it into the first part being this one and the second part being this one. The exponents, the powers of 10 with the exponents is the second part. And the first part is just the numbers. 6 divided by 1.2. Now, here is a little bit of a problem, because if we have 6 inside and a 1.2 on the outside, can you actually divide by a decimal? No, you can't. You have to move the decimal. So you have to then move a decimal here, and so it'd be 60. 12 divided by 60. Well, that's pretty easy because it would be 5. So the first part of my problem is 5. Now my second part. For my second part, what I'm going to do is I'm going to use my property of exponents. 10 to the 8th divided by 10 to the 6th is the same thing as 10 to the 8 minus 6, which then becomes 10 squared. Oh, look at that. 5 times 10 squared. It's also the same thing as 500, I think. Yeah, 500, but 5 to the 10 times 10 squared is fine. Is that what they put? Yes. I just wanted to make sure that they put that and not something else. So the second one, again, this is 1. This is 2. Now 3 divided by 6 is going to be 0.5. I know because 3 divided by 6 is 1/2, 0.5. So that's the first part. The second part is going to be 10, and it's going to be 3 minus 8. 3 minus 8 is a little bit of a problem because it's going to give us 10 to the negative 5. 3 minus 8 is negative 5. But you also have to move this decimal here because scientific notation tells us that we always have to have significant digit or a number that is not a 0 before the decimal point times 10 to the... So in here, that's what happens. When we move the decimal to the right, I need to show you because I think it's important for you to understand this, right? So if I have a 50 times 10 squared, right here, and I'm going to move it from here to here, it will become That wasn't that good of an example. Let me, 5, right? Yeah, actually, that is a good example. I don't know why I was doubting myself. But let's do 57, right? 57, and then we have to do the opposite. Let's move it backwards. Let's see what happens when we move it backwards. Times 10 to the 3. Let's just say that, right? So when you move it 57 to make it a 5.7, what you did was make it into a 10 times 10 to the 1 power. When you move it to the left, you add it, you put 10 to the 1 power, right? Times 10 to the 3 power, or the 10 cubed. Well, what are we going to do? What we're going to do here to get the tens combined is use another property of exponents, which is x to the a times x to the b equals x to the a plus b. So when we move it to the left, what we're going to do is we're going to add 1 here because it would become 5.7 times 10 to the 4th, right? This one is another example differently with this one, right? But the reason I have to do that is because if I'm moving it to the left and I'm adding 1, when I'm moving to the right, I'm going to subtract 1. So that one would be 5 times 10 to the negative 6. Oh my goodness, I wrote this different numbers here. 3 and 6, not 3 and 8. That's why I got a different answer. My bad. 10 to the 6, 6. It's going to be minus 3. I got what the book said. But yeah, please realize that I made a mistake because I thought it was a 8, 10 cubed and over 10 to the 8th power. But it was 3. 3 minus 6 is going to be negative 3. And because we move it to the right, again, that principle, moving it to the right will always be subtracting. Moving it to the left will always be adding. That principle stands. What the wrong part for me was that I put the wrong number here because I'm tired and I wrote the wrong number in the exponent. But this is how you do it. Now this one, okay? This one's going to be also a little bit tricky because in here, 2/8 is the same thing as 1/4. And 1/4 is the same thing in decimal notation as 0.25. That's my first part. My second part then is to put 10 minus 2 minus negative 8. Now this is very important because negative and negative is positive. Positive, right? And so negative 2 plus 8 is going to be 10 to the 6th. Right? Negative 2 plus 8 is the same thing as 8 minus 2, which is 6. So then we have 0.25 times 10 to the 6th. Now I'm glad that I went over this already because since we have to move the decimal point here, why do we have to move the decimal? Because scientific notation requires us to have a number that's not 0 in front of the decimal. So it'd be 2.5. And we have to subtract 1 times 10 to the 5th power. And if you look at your book, that's what they got. And that's what I got. The only one I got wrong is because I thought it was an 8, but it was a 6. Even if it was an 8, but if it was an 8, I would have gotten it right. So let's actually move on to the last example. But this, for the most part, will tell you what to do. It's not that hard. Divide it into 2. First by the numbers, then by the exponents. Okay, so before I move to example 2, I know it's a lot closer than most people thought, but I'm going to do, again, some bonus points. This time, the first 5 people to comment on the YouTube channel in the comments below, you have to comment, what is your favorite sports team? Okay, And if the girls don't have a sports team, you can actually say the LGCS boys soccer team, which is pretty good. I mean, we won the state championship banner. Yay, we have a banner. So you could put that if you want. The point is that I want to make sure that people are watching the videos. It doesn't really matter if you don't have a favorite team. Now, for those of you who get too late and can't comment, remember, it's the first 5 comments for YouTube and the first 3 comments for Google Classroom. So the first 5 comments in YouTube will get 3 points. The people in Google Classroom will get 2 points. So YouTube, 3 points, Google Classroom, 2 points. The ones in Google Classroom, and these are 3. So I'm doing it for 8 people out of 14. That's a pretty good deal. For the 3 people in Google Classroom, what you have to write is, what is your favorite show? And I'm not going to say TV show because you guys don't watch TV. Some of you just watch Netflix and Disney Plus and Hulu and stuff like that, but they have shows anyway. So you just tell me what your favorite show is, and that's it. So the ones in YouTube, tell me what your favorite sports team is, and the ones in Google Classroom, tell me what your favorite show is. Now, understand, it's only for the first 5 people in YouTube and the first 3 people in Google Classroom. You cannot get double points. If you put a comment in YouTube and a comment in Google Classroom, it doesn't count. If you put it first in Google Classroom, then on YouTube, I'm only going to give you 2 points. But if you put it on YouTube first, I'm going to give you 3 points. So please understand that. Let's actually move on to the next example in the lesson. All right, and the final example for lesson 111 is the distance from the Earth to the Sun in kilometers is 1.5 times 10 to the 8th kilometers. And the rate of speed in which light travels, the speed in which light travels in kilometers per second, is 3 times 10 to the 5th kilometers per second. So 10 to the 5th is 5 zeros. So it's 3 followed by 5 zeros, which is 30,000 kilometers per second. No, it's more than that. It's 300,000 kilometers per second. Yes, 300,000 kilometers per second. So, what is the question then? The question is, how long does it take for the sunlight from the sun to reach the Earth? And so, the way that we do it, obviously, is by dividing. So, we're going to put 1.5 times 10 to the 8 kilometers. Well, let's not worry about units. And the reason is because the units, since it's in time, is going to be seconds. We know it has to be seconds. So, but we need to put units. That doesn't mean that you can just forget about the units. It's not what I said. So again, divided into 2 parts. The first part, 1.5 divided by 3. Now, in here, you could actually do this. You are allowed to do this. So 3 into 1 is 0, but into 15 is 5. So I get 0.5. And 10 to the 8th and 10 to the 5th divided by each other, 10 to the 8th divided by 10 to the 5th is going to be 10 to the 8 minus 5. 10 to the 8 minus 5. That would be 10 cubed. Okay, so I got 0.5, 10 cubed. However, this has to move to the right. And every time I move to the right, it's going to be subtracted by 1. So it'd be 5 times 10 squared, or 500. 10 squared, because 10 squared is 100. Everybody knows that. And 100 times 5 is 500. 500 seconds. It will take 500 seconds. 500 seconds divided by 60. It's less than 10 minutes. Because 600 seconds is 10 minutes. So 6 times 4, 6 times 9 is 54. Less than 9 minutes, too. Oh. 6 times 8 is 48. 8 minutes, 20 seconds. That's what it is. 8 minutes, 20 seconds. So it takes the light from the sun to the earth to roughly about 8 minutes and 20 seconds to reach it. And that's it. This is it for lesson 111. I'm getting more excited by the day because we are almost ready to finish with the book. But this doesn't mean that we're done with math because we have the test coming and also the end of course exam. Yay! So there's more stuff to come. Do not worry about tomorrow, for tomorrow will bring its own worry. That's what the Bible says in Matthew 6. So let's just take it a lesson at a time and a day at a time. We'll see you then in the next one. And I hope you have a good weekend. Yay!